Hi guys, the busy one, this one. I am going to, I was going to split it into two videos, but I ended up just doing it as one. The first part of it is all about setting up the repository for this code, and then the second half I do some tidying up of the existing code, making a game controller and sort of hiving off various operations to that, and then we get some guardians, so we get some enemies, bad guys, whatever you want to call them, inside the game, and all of this happens after the fade. Okay, so this is kind of behind the scenes of the source control that I use. I use Bitbucket, as you're probably maybe not aware. If you want to get access to this repository, the link is here at the top of the screen, but if you can't read that for whatever reason, you're using it on like a little tablet or a phone or whatever, the link is in the notes below, the video description just down below there. So if you want access to this here, I'm trying to get ahead of myself, so what I want to do is I want to create another branch for my new video. So right now I have a few branches here for YouTube source repository. Is this the right one? Maybe this isn't the right one. YouTube tutorials. Last updated 2 hours ago. Yeah, is that one? I don't see why. Maybe I don't have any branches. Okay. Well, I want to create a branch anyway. Actually, first of all, I want to push this change here. I have a change here, and I'm going to upload that to there. That's good enough. So this is the source control that I used. You know, I used to use Perforce, but this is easier. It also means that I can publish things up here, and I don't know if Perforce has this functionality. So if you do know and you're aware of this, then by all means use this. Use Perforce rather than this, but this is the one I use. There's GitHub, there's a whole bunch of other ones. I'd highly recommend, if you're doing any project, no matter how big or small. I have Crash Plan on this machine as well, and I back up all my source code to Bitbucket as well, so that's my source repository. If you don't do that, I recommend you start immediately doing that, because if your machine goes down, you lose everything. And I can't stress this enough. You need to be able to recover from that. Now, hardware is cheap. It's a couple of $100 for a hard drive. Maybe $400 for a CPU, whatever that is. But think of the amount of hours of production that you've put into your data. It's irreplaceable. There's no way you can get that back. Just the sheer cost of it. Even if you say, let's say it's $50 an hour, and you spend 20 hours doing something, that's a lot of money. Was that $2,000? Something like that. Whatever it is, it's a lot of money, and you can't get it back. And not only that, you have to try and remember what you did to get to that point. So you must have some kind of source code repository. Anyway, that being said, I want to create a branch in here. So this is my local thing that I use. I also sometimes use the command line, but I want to use this one here. So I want to create a branch here, and I'm going to call this Manic Miner, and this is going to be horizontal guardians. This is going to be horizontal guardians. Okay, so that is my branch, and that is how easy it is to create your branch. Now what I want to do is I want to check this out in source tree. So right now I have it locally. So what I want to do is I want to I have it remotely. I want to have it locally. So I click on the check out in source tree button, and it should bring up here. If it doesn't, what you can do is you can actually do fetch from origin. That'll go away and not work. Why that not work? Fetch from origin. Come on. Really? Why is that not working? This is just typical. Check out. Yeah, there we go. Check out Manic Miner horizontal. Check out in source tree. Why is this not working? Okay, I swear this is. Why does this always do this for a video? Okay. Well, I guess we have to do this there. Oh, there it is. There. What? Okay. I don't know. Whatever. Okay, so this is the branch that I want here. You notice that we have it in remote branches and we have local branches here. Well, I'm going to double click this, and what this is going to do is this is going to make a local version of that branch. Now that means that when we make changes to the branch, we're making it just to that branch. We're not making it to the master branch. We're just making it to the local branch. In fact, nothing gets set on the server at all. So local branch should track remote branch. Okay. And that's going to work away for a couple of seconds. And why is this taking so long? There we go. Okay, so that is there, and there we go. So now we are working in our local branch called Manic Miner Horizontal Guardians, and that's it. We can now just work as if we would normally work. So we go to here, and it's the exact same code that we had in the master branch. The difference is when I make any commits now, I commit to this this branch here. So what this means is I can I can make changes to I can make videos in advance, because unfortunately pressures of work and all that kind of stuff, I'm finding it difficult to like have a set time to do things, so I have to kind of get them in the ebb and flow. But I still want to have a video out every Monday. That's my goal. That's in my head, that's what I want to do, is I want to have a video every Monday. So what I'm going to do is I'm going to try and stack up some videos when I can, and in that way you guys get a video every Monday and I get to make videos, which I really enjoy making. And that's what I'm trying to do, is trying to work around all of this. So anyways, this is a a little kind of bonus extra content type thing, just to show you sort of what happens behind the scenes. Because this is running on the web, you can make a pull request. You can make any changes to the code. Everything is up here. So if I click on source, for example, and so I have my master branches and all that kind of stuff. So this is the master branch. So if I go to Unity here, I can see the Manic Miner remake, and then I can go to assets, and what else can I do? I can go into scripts, and I can look at the spectrum screen, for example. So I can have a look and see what the spectrum screen is, and then I can actually I can see what the differences were. So I can click on diff, and it shows me what the differences are. So if you've never used source control before, this is an amazing tool. So you can see here that I removed all this stuff here, and I added this. So it's kind of an overlap. It kind of goes crazy, but at least it kind of highlights the differences between the files. So this got deleted and it got replaced with this tooltip and so on. And similarly down here, this was added new, which is the print message, which we did in the last video. And yeah, so that's kind of where we are here. And obviously I made that public, so now that instead of clear X, it's now clear. And then I changed clear X to clear. So you can see all these things. Maybe I can zoom in a little bit more. So you can see all these changes inside the file, and that's a great thing to go back as well. So you can actually find out, why did that change? Then you can look at the change list. You can find out what it was for, and then you can click on. If I go back to, you can actually do a side-by-side diff as well, so you can see what actually changed between the two files. So in this one here, I moved the flashing timer down, and I added this spectrum font, and then over here I could make these changes here as well. So it's a great handy tool to have. And I highly recommend that if you don't have source control for your own projects, then you should look into something like Bitbucket or GitHub or something like that, where you can put these repositories up and yeah. So anyway, your code's safe there at that point. That's kind of my point, is that your code, your assets, all that kind of stuff, they're in a nice backed up, you can always get to it type place. And the great thing is, if you have like you have two machines, rather than taking the old sneaker net way of doing things, you get a USB key and then you take that out there, you plug it in there, you send your friend a zip file or whatever it is. These are great, but the problem is that changes tend to get lost. Whereas if you're always submitting to a repository, your changes, your canonical version of your code is always here. So you can have like release versions as well. So what a lot of people do is they'll have a branch. So I have a main branch here. I don't see why that's... See, that's not showing... Why is that not showing master? It's just showing... Yeah, I don't understand why that's just showing the master branch, because clearly I have more than one branch. But anyway, so inside here you would have like a release branch, and you would have, maybe you've got one that you sent to Sony, or you sent to Xbox, or you sent to, I don't know, Steam, whatever it is. You'd have different release branches there. You can make a change there, and then you can bring that back into the main branch, and then when you want to bring that back out to other branches. Anyway, there's a whole slew of things. This is just an extra kind of bonus video just to sort of show you kind of what I do behind the scenes. Anyway, that's kind of all I wanted to really kind of cover just now. On that, what I want to do though is I want to get back to the Manic Miner video, which is it's coming up next. Here it is. Okay, so today I want to get in horizontal guardians, and there's a couple of things I want to change, because obviously this is getting too bad. We've got a lot of hacks in here. So what I want to do is I have a room here, ZX Spectrum, and then I'm going to have another one here, and I'm going to call this what am I going to call this? Game? Something like that. Actually, let's call it controllers. And then I'm going to have another script in here, which is going to be a mono behavior, and it is going to be called game controller. And game controller is now going to have everything in here apart from the renderer. So this is going to need it's going to need the room store, it's going to need the spectrum screen, and it's also going to need the room renderer as well. Type of, and then this is room renderer, and spectrum screen is inside there because we get it from a different package. Okay, so that is I'm just going to move over here a little bit. Okay, game controller. All right, so my game controller, now this is what I want to do, is I want to have it so that the game controller or the room renderer itself doesn't know exactly what it needs to render. So I want to offset those values. So the first thing is I want it to have okay, so the air supply is this value here, but I want to expose these values to the room renderer, but I don't want it to, do I want it to have knowledge of that? I guess maybe. Yeah, see, all of this is just ugh. So I want all this to come out and be sort of separate. Somehow, like all of these controllers and things, they need to come out and go into game controller. So I think what we'll do is we'll get the air to come out first, okay? So our room store, our room data is from here, and our spectrum screen sprite renderer. Do we even need this? I don't even think we use this. Do we use that? No, I don't think we even use that. Let's tidy this up a bit for now. So this is I'm gonna spend the first I'll maybe put this out as like a part A video, and then there'll be a part B on top of that. So that's not good. I guess we do need that. That's kind of bad. Why is that in the room renderer? So this is why we need comments. Okay, so right. This is the spectrum screen, and then we want to target get component SR sprite. Why? What is target? What is target? What did I do is target? Target is spectrum screen. And spectrum screen, okay, is just that there. Alright, okay. Alright, I think I know what this is. Alright. Okay. So, spectrum screen is our abstract concept of drawing things on the screen. But we still need to be able to write it to a sprite renderer. So that's what this bit in here does, is it creates the texture. Sorry, I'm just going over what we did before. So, all right, okay. All right, so here's the room ID. So we don't need that in here. So I'm going to get rid of that. And I'm going to put that in here. And I'm going to say tooltip, name, the room number. 0 to 19. Okay. In fact, there you go. That's it there. And so that gets rid of room ID, which means we need to be able to get the room from here. Okay, so while, so we still need that in there. So we're going to do public, I enumerator start. So again, we're going to make that an enumerator start, so it's going to be a coroutine. So while the store is not ready, which we haven't got yet, so store is get component room store. And we don't need, do we need store? I don't think we need store beyond that. I don't think store gets used anywhere else. Yeah, store gets used there, and that's it. So that's fine. And then our room data is this here. Now we want to expose that room data. So I want to say public room data room data get return room data. Okay. And then we'll do room data, and then we'll have some private member fields up here. So private room data, room data. So this is our private member fields, public member fields. Okay. Public properties. All right. Okay. And in fact, maybe what we want to do is we want to send that data to the room renderer. Yeah, we want to do it somehow, because that store is not going to get used there, and data is not going to get read in from there. In fact, all this is going to do is it's just going to draw the room. So, so this is draw routine data. Okay, so we have a draw screen, which is a coroutine. So all we need to do is we need to have public void draw screen, and then we pass in our data. Aha. And so we don't need that. We don't need that. What's this complaint about? Room data cannot be an iterator block because it's void. Yeah, that's true. So we can get rid of that yield there. Because what we're going to do is we're actually going to use that coroutine on the other side. So our room data is here. So we don't need to expose this because I'm going to do a start coroutine draw screen, and then we're going to pass in room data. Which of course we probably don't need to pass in, but whatever. Numerator draw screen, and then we're going to do while game over. So while it's not the game over, then we're going to do renderer. That's not called renderer, it's called something else. We need to call it something else. So room renderer, we need to grab a hold of. So private member field, so we're going to do private room renderer. Actually, we can just pass that in there. So we can just do that there. So we can do var room renderer equals get component room renderer, and then we just pass that in with our data, start coroutine, and then our room data. Room renderer, and then room data, and it's going to be room render draw screen room data. Okay, so now all the logic is going to go inside this class, and that room renderer is all it's going to do is render the room. That's it. So we don't need that there, but we do need game over. So private game over. So game over is currently false, and then we need to do yield return null. And then we are going to do start coroutine, and then it's going to be, what's that one? Lose air, that's it there. So this is what we need to do, is take that out, put that in there, and then our lose air is going to be a little bit simpler. So we're going to do while not game over, wait for a second, and then I'm going to say, so our room data, let's pass in room data again. So we'll pass in room data, which is no longer a hack. So we're going to say room data dot air supply dot tip equals that, and then we do the same thing again here. So we clamp that to less than there. So that's we need to do this as a byte. So what we could do is we could actually make these extensions and then tidy up the code a bit. That's the good thing about extensions, is that your code tends to look a little bit nicer. So I'm going to say if airsupply.tip equals 0, then I'm going to reduce the head by 1, and I'm going to say room data.airsupply.tip equals 255 if room data.airsupply.length is less than 0, game over. Actually, I could simplify that. I could say game over equals length is greater than or equal to 0. Sorry, that would be less than 0. So game over is when the air supply length is less than 0. Okay, so that's our lose air. And so now we get rid of that. Don't need that. We don't need any of this code in here. That only sets up there. We're only waiting for the store for no reason. Because we don't need that, because this never gets called unless we explicitly call that, and then that just becomes a void. And actually, we can make that an awake now. So we'll make that an awake, and we don't need the high score because that comes out of there, and then we don't need that anymore. In fact, we do need that high score out of here, and we don't need room store. We do need spectrum screen, and we do need target, and that is it. That's all we need for our room renderer, which should have everything in here, and then we'll figure this bit out here because this is all totally wrong now. So, and again, our controller here doesn't know anything about rendering. It just needs to know what information to send. So our score is going to be in there. So we are going to supply that when we draw the screen. So we draw the screen, and then we pass in the score. String.format score format, and it's going to be high score, and it is going to be score. And that will be string player score. So now our player score is going to be just player score. So again, it doesn't know anything about it. Get rid of collections because we don't need that. We don't need spectrum store because we don't load anything. But the only thing we need to have is spectrum screen because we need to be able to draw things. While air supply length is that, we don't need that while loop because this is just going to blindly draw things on the screen. So we don't need that while loop. And then the next thing is we've got to fix up this air supply length. So I'm going to do var air supply length equals room data. Is it not called room data? Oh, it's just data. Data.airsupply.length var air ed equals data.airsupply.tip, and that should fix those red marks down the side there. And our game controller should just be enumerators. It should just be ticking things over and over. So we have this one running every second, and we have this one running for as long as it takes, as many updates as possible because we want the screen to refresh as much as possible. And then this one here, all it does is it waits for the store to load, and then creates the screen, and then creates the two coroutines to draw to the screen and to lose the air. Okay, so fingers crossed, nothing should have changed, everything should be fine, and we should just be able to play the game, and nothing works now because I've forgotten something, clearly. It's always good to see a purple screen. Oh, I know why. Because in my loader test, I need to add game controller. So now my game controller is the one that controls all of these things. So my room renderer, my room store, my spectrum screen, all that kind of stuff is all done from this one object. So now, seriously? I said that with so much confidence as well. Start coroutine, draw screen. So why? I'm not even getting any errors. That's the strange thing. Help. So it's not like it's drawing anything. So there's the spectrum screen. The sprite's not getting set. So room render, why is that not getting called? Let's put attached to Unity here, and then we will see if draw screen is getting called. Okay, so that's getting called. Background grid. Oh. 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 That's null. Why is that null? Spectrum screen. Because it's on awake. That's why this is on awake as well. We end up in a race condition. Okay, let's make that start. So that'll happen after there. I mean, we could do the same thing with... Yeah. Okay, so there's Manic Miner again in all its glory, and you can see that everything's still working, and our air supply works fine. And we can change room ID, so let's go to the cold store. Here's the cold store. You can see we've got a couple of issues here because we don't have the right attributes for the objects just yet, because they actually flash and do weird things. Let's go to Eugene's layer, which I think is 5. Yeah, there you go. And again, these are apparently these are supposed to be credit cards, but it's 8 by 8 pixels, so I mean, what can you do? So yeah, that's Eugene's layer there. And then we can go to, I don't know, Wacky Mobitrons or whatever it is. The VAT. There you go. And that's that there. Okay. All right. So a little bit of tidying up. We had to do that. Had to do that. And we can make this a little bit easier as well on the eyes, because we can actually take this out and let's do a refactor here. So quick actions and refactoring, extract method, and I'm going to have that as draw room. So that's draw room, and I think that might be the attributes as well. Let's draw the portal attributes. Where's the portal? Draw room keys. Okay. I don't know why that's separate to there. I'm going to make that quick actions, extract method, and that's going to be draw portal. And it's going to be draw items. Draw items. And this is draw room title. And this is draw air supply, which is kind of huge. Supply, and then draw the score. Draw score. Okay, that makes it a little bit easier-ish to read. Certainly makes this a lot easier to read, because then we can start drawing other things in here. So we're just blitting these things on the screen, so we're not again, we're trying to separate the controller from the actual view, and try and do things a little bit more object oriented than maybe Matt Smith would have done back in the day. I mean, don't forget he had 48K to play with, 16 of which was ROM, another 8K was screen memory. So I mean, you're down to 24 or whatever it is there. So he didn't have a lot of memory to play with in this. Okay, so that's that there. The Guardians, these are in here. So the Guardians are here. Horizontal Guardians. Each room can have 0, 1, 2, 3, or 4 horizontal Guardians. All rooms can have these. Unlike Jet Set Willy, all horizontal Guardians in the room have the same graphic. Guardian graphics are defined separately within room data. We'll get to that in just a sec. Up to 4 horizontal Guardians can be stored in offsets 702, each represented by 7 bytes. Okay. So the 7 bytes of each horizontal Guardian are as follows. First byte represents the Guardian's color attribute. Okay, so I am going to have a new class, and I'm going to call this class C# editor script. No, I just wanted that. I'm going to call it Horizontal Guardian for just now. It might be different, so we'll leave it as that. So I'm going to do public byte attribute, and then the second, third, and fourth bytes represent the starting position of the horizontal Guardian. So that is just going to be public int start x, set public int start y. We'll figure that out in just a sec. The above word format, the fifth byte represents whether the Guardian initially goes right or left. More precisely, it's which frame of its graphics the Guardian starts on. Sprites 0 to 3 are the frames facing right, 0 recommended. Sprites 4 to 7 are facing left, 7 recommended. Value greater than 7, so that would be public int start frame. And then the 6th and 7th bytes represent the extreme left and right positions. Okay. Where x is the horizontal position, the boundary and the number of characters right from the left edge of the screen. From the left edge, refer the character column of the left half of the sprite. Y is a slice of the vertical position, which of course is the same as the second byte of the Guardian. As horizontal Guardians do not change the vertical positions. Although the starting position always falls within the left and right boundaries, and all original Miner. Okay. 6th and 7th byte. So that's going to be public int left get set, public int right get set. So those are the extremes of movement there. Okay, so there's my horizontal Guardian, and then for my room store, I need my room data to change as well. So my room data is going to have public list horizontal Guardians, private set. So that is going to then say equals new. So just send this up the same ways that I did for the room keys. I'm just going to have this list in here, and then I'm going to read them in one at a time. So I'm going to do, where did I have this? If add key, that was it. So I did that there. So so just after air supply, I'm going to do for int g equals 0. So g is for guardian. Actually, maybe we should do h equals 0, h less than, how many horizontal guardians can we have? We can have 0, 1, 2, 3, or 4 horizontal guardians. So 4 h plus plus horizontal guardians. And then I'm going to do horizontal guardian or hg equals new horizontal guardian. Hg dot attribute equals importer dot read, and then to get the the position, we did this before. We did this before. We did this for appendix D, and okay, so this is YYY. So YYY represents the vertical starting position for these two values here. So the first one I'm just going to ignore. So I'm going to do importer read ignore this byte. And then I'm going to do importer dot read short. And then this is going to be the positional information. The positional information for the guardian. And I'm going to do pause dot and then get x. Okay, I can do that. Okay, get x and get y. Okay, so hg dot start x equals pause dot get x. Get y. Okay, and these are character positions. So I'm going to put a block at that character position. And then I'm going to say if hg.attribute is not equal to 255, I'm going to do data.horizontalguardians.add hg. And the fifth byte represents the initial frame, so I'm going to do hg.frame equals importer.read byte. And the 6th and 7th bytes represents the extreme left and right positions. Okay. So our hg dot left equals left and right positions. Okay, so that's going to be importer dot read. And then I want the 1, 2, 3, 4, 5. So I want that to be 1F and OX1F. And then my right, I want it to be the exact same thing again, but for the right. Okay. And that should be that. And then in my room renderer, I am going to do, what am I going to do? I'm going to do draw horizontal guardians data. Okay, and then for my horizontal guardians, I am going to go down here and do private void draw horizontal guardians room data. And then we say for each horizontal guardian G, actually we just do var G in data.horizontal guardians. I don't have the data for this just now. So what I'm going to do is I'm going to say byte graphic equals new byte. And then it's going to be 4 times 8 in size. So 4 eighths is what, 32? Array dot, can I do array dot fill clear? Is it clear? I can do clear. No, I don't fill it with a value. Or not. Okay, so for int I equals 0, I less than graphic dot length I plus plus, graphic I equals 255. So I just want to fill it in with 255, and then I want to do draw screen dot draw sprite, and then it is going to be my g dot. I'm just going to have this as start x just now. G dot start y columns, which is going to be 2, and it's going to be rows of 2, and then data is going to be graphic. And then I want to do screen dot set attribute, and then it's going to be I want to draw a rectangle though for that. Spectrum screen. So set attribute is there. What I want to do is I want to have public void fill attribute. Int x, int y, int rows, int columns, int paper, int ink, int paper, bool right equals false, bool flashing equals false. So rather than having it as, you know, just this here, so it's complaining about. Oh, it does. What? Why am I not using that then? What? I've already done this. Why am I using that then? Okay. Screen dot fill attribute. Apparently I'm cleverer than I thought it was going to be. X. Y. Oh, it's going to be G dot start X. G dot start Y. And then it's going to be width and height is 2. And then ink and paper. I'm going to make that 6, 0, and then just leave it at that, because I need to figure out how to get the ink and paper out of there. Actually, no, I can do that. I can do g dot attribute dot ink. I think I can do ink. G dot attribute dot paper. Do I not have byte extensions? Bool array extensions. Attribute extensions. Okay, I can do the same thing for a byte as well. We do byte, and that's going to be byte, and that is also going to be byte. There you go. Save as rewriting everything. So now our attribute Oh, get ink. So that's going to be get ink, get paper. All right, so now our attributes are now filled in, and we should, fingers crossed, have one guardian in this room. There we go. He's not in the right place, but we have a guardian. So the guardian is over there. That annoyingly has now got a missing brick. So let me just comment out our guardians first of all. Okay, so something's wrong with our guardian, because it caused these two bricks to not show up. That's kind of off-putting. Okay. So let's find out where our guardian is. So our guardian should be, if we go back to our Manic Miner Central Cavern. So where do we go? We went to this one here. So he should be about here. That should be where he starts, roughly. And he's clearly not starting there. So we'll find out why he's not starting there. So I'll go to my room store, and I'll set a breakpoint there. And we will... Okay, so start X is 28, which does not seem right. So the position is that, which is hexadecimal display 605C, which calc hex 605C, which is that in binary. So according to our, where are we? Appendix D. Yahoo. See, we don't actually have that much to go. We've got these there, we've got color attributes, and then we've got D word formats. Okay. So our first positions here are 1, 2, 3, 4, 5. So that's 1, 2, 3, 4, 5. So that is 1, 2, 4, 8, 16. So 16 plus 8, yeah, it's 28. And then the Y value is the first 4 there. So that is 1, 2, 3, 4. So that's 1. So that means 1, 2. So that would be 2. So our next value should be 2, which is right. So, I mean, why is that 28? Is this in here? So what's the next one? So the left and rightmost ones, left is 8, right is 15. The left is 8, right is 15. So is that right? 1, 2, 3, 4, 5, 6, 7, 8, and then 15. That sounds about right. 8 to 15. That looks like 8 to 15 to me. Okay, so the leftmost one is coming in right. So my calculations are weird. I don't understand why my star X is wrong. Okay, X. Yeah, is that So that is 1, 2, 3, 4, 5, which is right because it is 1, 2, 3, 4, 5. So that is 1, 2, 4. 4 and 8 is 12, and 1 is 16. So 16 plus 12 is 28. Why is it coming in as 28 though? And then what's the first one? Let me just go back to why is that coming in as 3 bytes? Wait, I'm confused. 605C. Okay, that's 0110. 1, 2, 3, 4. It should be ignoring that. I don't understand why. See, it should only be showing these two values. That doesn't look right. 73, 70, oh, 73, 74, 75. Oh. So I should be keeping. Oh yeah. Okay, right. Okay, I know why. What I should be doing is I should be reading that backwards. Ignore this bit. Because it is little endian, which means it's backwards. So he's not there anymore. Okay, let's see where he's coming in at now. Okay, so start X is 8, start Y is 7, sounds good. Start frame is 0, left is 8, right is 15. Okay, alright, so I think I can go back to my room renderer and I can re-add my Guardian of the Galaxy, and now I have my block in here. Okay, so my block is going to move at a certain speed, but I don't know what the speed is. And also the way that the spectrum works, or the way that Manic Miner works, is he moves it 2 pixels at a time, but the animation is not that. So yeah, it's kind of weird. It's anyway, we'll come to that in just a sec. All right. So these are the vertical guardians. We don't want to do them just now, but we kind of need to get rid of these values. So that's the horizontal guardians, and then the next one is the vertical guardians. And each one of those is 7 bytes as well. Okay, so 7 bytes for 7 brothers. So these are our air supply. This is the horizontal guardians. Horizontal guardians, and then we need to do vertical guardians. Yeah, I'll just comment that out. To do need to add to vertical guardians. Color 375, Skylabs, special graphics, 736 to 76, that. Okay, so here's our special graphics. So I'm just going to call them special graphics. Okay, our special graphics is just going to be a series of blobs. That's all they are. So I'm going to draw them that way. I'm going to go into my room data, and I'm going to say public list byte array special graphics, and getting set. And for the special graphics is there, so that goes from 36 to 67, which is 32. So I'm going to do for actually it's just going to be byte special graphic equals importer dot read bytes 32 data dot special graphics dot add special graphic. So instead of the horizontal guardian for just now, excuse me a second, I'm going to use the special graphic inside the room render. So instead of drawing the graphic like that, I'm just going to say data.special graphics 0. I'm just going to use the first special graphic, which according to this is the swordfish graphic. So we should see a swordfish when we run the game. Or null, we'll get a null. Special graphics is not, okay, that's why. So I'll go back to room data and we'll do that, close that. Okay. Because I never set up my list. And now that the list is set up, we now have, whoa, craziness. Okay, and I think that's because we need to draw, that's got to be done by doing a row attribute, row order sprite, I think. Or maybe column order sprite. We'll see. No, I think it might be column order sprite. Column order sprite? Anyone? Nope, definitely row order sprite. So there's something wrong there. Let's try special graphic one. It's nice to see these things anyway. See what we got. Whoa. I did not like that. Why did that not like that? This does it for every single room, doesn't it? Import room. Yeah. Oh, because it's room data. Of course. I don't have access to that. Oh, it's room data. Room store, room data. Okay. Okay, well, we'll just do that as 0. So, yeah, we'll need to figure that one out as well. Okay, well, it's kind of, I realised that was a swordfish. I don't know why, I didn't think that was a swordfish. I mean, I guess maybe it is. I don't know. We can actually show the second room. So I'm going to show room ID 2. Yeah, these are wrong. These actually look like the Guardians. You see color clash is working now. These actually look... This looks wrong. Okay, so I think this is wrong. I'm all over the place here. Okay, so that's the special graphic. So let's go back up to horizontal guardians. We did, and then vertical guardians. So these are any room to vertical guardians. That's specified by offset. And like just well, all vertical guardians are the same graphic. 4 vertical guardians. If there are fewer than 4 vertical guardians, 7 bytes of each vertical guardian. So 7 again. Skylabs. Special graphics. Okay. 16 by 16 graphics associated with them, which is 2 by 2 characters, which is 32 bytes. So 0, 1, 2, 3, 4. But those don't look right. Those look like how many of these am I reading in? Okay. So 1, 2, 3, 4, 5, 6, 7. Okay, 7. And then we get 7 on top of that, which gives us the 1, 2, 3, 4, 5, 6, 7. And then we read in the special graphic. Which did not look like the special graphic. It really didn't. I mean, if I go here, that's probably going to be the... Yeah, those are those guys. See, that's got a bit of the special graphic. That's the boot from the special graphic. So yeah, these are wrong. And then 0 is going to be the swordfish. A little bit of the swordfish. So what is offset that? So is this variable then? These here. As a special case, is not guarding this sensitive section. For rooms which don't have vertical graphics, 73, 74, 75 are all set to 0. And so are offsets 736 to 760, except for rooms 0, 1, 2, and 4, which have special graphics. Oh, okay. So special graphics go where? 736. So they go in the same place. Okay. Well, that's just peachy. 733, 734, 735. And then 736. Okay. So I need to know what room number I'm in now. import room, and then I'm going to do bool as special graphic. And as special graphic is going to be room is less than or equal to 4. So if the room is less than or equal to 4, 0, 1, 2, what? 0, 1, 2, and 4? Matt, seriously. 1, 0, 1, 2, and 4. Wow. Okay. Is special room I. And I'm going to generate this method, and is special room. Return I is greater than or equal to 0, and I is less than or equal to 2, or I equals 4. Don't like that at all. Okay, so is special room. Oh, you're special, all right. So it has special graphic. Okay, so if it has a special graphic, so if special graphic else do this, else do this, so if it's got a special graphic, then I want to ignore the first 3 bytes. Is that right? 736. So I'm at 733 just now. So I want to ignore 733, 734, 735. 3 bytes. Okay. So importer.read bytes 3. And I just want to ignore the first 3 bytes. Ignore offsets 733, 734, and 736. Okay. And otherwise, I need to figure out if they have something in here. So if attribute is not equal to 0, then I want to add it, because it said, where does it say it here? Horizontal, vertical. Offset 73, 74, and 735 are set to 0, and so are offsets, whatever it is. So I just need to set it to be 0. Okay, so we'll do that then. That seems fine. So now we should have a full graphic in here. So okay, that looks fine, but I think we need to make that the other one. Column order sprite. So we'll do a column order sprite there. Oh, that made it worse. Unless there's another way of doing it, I don't know. Well, let's see what the boot looks like, actually. So if we go to screen 2, screen 1. So that's the column, so that's reversed. And then the boot should be there, which is also reversed and slightly offset as well. Oh, Matt. So it's kind of nice. You can sort of see where these are starting. So this is a green duck, if I remember rightly, the menagerie. So, and these are red and purple, so you can sort of see where they start, and you see that this starts in the boundary there, and so on. So that's pretty cool. And then the last one was 4, wasn't it? 4. So yeah, there's Eugene there, and he's drawn wrong. And there's another Guardian there, and there's one up here. That doesn't seem right. And then there's another one. We did one. I think we did one. Yeah. So I need to figure out why. Oh, okay. So we have to draw the portal on top of everything else. I think that's right. Draw portal. Yeah, draw portal. Make this the last thing drawn in the room. And then, so let's find out why. So this is, let's look and see what this is. So this is supposed to be the, maybe we can see it better with the boot. Oh, that was weird. It's like they faded in there. What is going on there? What is going on there? It's weird. It's like it's getting half the data. There it gets all the data. So that is in the wrong position. That should be on the foot. This should be shifted up, and this should be on the other side. So we're missing. It's hard to see what's happening here. So this should be on the other side. Should I only be doing 2? Is that what that is? So it should be 3, 34. Let me or it should be 37, 36. Read bytes 1. Should I not be ignoring any bytes? It seems kind of counterintuitive. So, what does it say again? Oh no. What? Okay. So vertical guardians for only for rooms which have them. So 733 to 760. For rooms that don't have vertical guardians, 733, 734, and 735 are set to 0, and so are offset 736 to 760, except for rooms 0, 1, 2, and 4, which have special graphics. Special graphics. Okay, so special graphics is held in offset 736 to 7, so standard. So just to confirm here, 767 minus 736 should be 32. Yeah. So 736. Yeah, that's right. On other screens, 761 to 767 are zeroized. hold room holds the plinth graphic, holds the boot graphic. So 1, 2, 3, 4. Read byte is 4. So it's 4 8s, so it's 1632. Okay. 736. Okay, so what position am I at this point? Oh, it's so difficult to tell from that importer though. Let me see if I can get a logical address. So call the first 27. Flush. Okay, and then offset is there. So I'm gonna say offset is that minus 1634. Okay, I think we can maybe find out from here. Gonna have to find out somehow. Well, let's look at this logically. Okay, so it says here that 733, 734, and 735 are 0. So if we're at 733 here, but if I put it at 0, it got me more of the graphic. This made no sense. Okay, special graphic. Importer is currently at position 29402. Okay. Calc plus 16384, which is 45786. All right. 45768, which is 45056. So minus that 45056, which is 730. So I'm at 730, which is what I should be. Is a terminator. Okay. So 730. So $730. Why am I at 730? Row 730. That makes no sense. If I'm at 730, how am I at 730? 730 is a terminator which is always set to 255. So if that's the case, then when I read this in, the first byte of that should be 255. Why am I at 730? Am I missing something? Did I miss something from air supply? Maybe. Let's go back. Okay, so horizontal guardians. But I know the horizontal guardians are right because those are the values that are there. Oh, okay. Offset 730 is a terminator, which is always set to 255. Offset 731 and 732. Okay, so maybe I just need to, instead of ignoring those bytes, I want to ignore those 3 bytes, and I also want to importer dot read bytes 3 always 255. I did miss them out. Always 255 and 0 and 0. And I'm going to copy that there. I'm going to paste that in there so that I can remember what that is. Okay, so now, whew, okay, all this just to get graphics. Okay, there we go. There's the boot. And then if I change this to room 0, too much to ask. So if I change this to room 0, I should get a swordfish in here now. There's the swordfish. It's a fish and a sword. Do you see what he did there? And then if we go to 4, we should get Eugene in his lair. There we go. There's Eugene there in his spectacle glory. Named after Eugene Evans, who was the sort of child prodigy of Imagine Software, who was like promoted by Bruce Everest, and it was like, you know, he's a millionaire and all this kind of stuff. Turned out it was a load of garbage, but people did buy into it. Okay, so that's us. We have our graphic there. So now that we've got that, let's see if there's any other crazy stuff in here. No, there's nothing else. So there's the special graphics there. And now we have the Guardian graphics. Okay. So 8 16 by 16 sprites for all Guardians are held in offset there. Varies from room to room. Particularly extremes right to have bidirectional graphics. 0, 1, 2, 3, 4, sprites used in the following different ways. Okay, so we probably have to do some kind of weird controllers for each of the rooms, which is fine. Okay, so sprite 0, 1, 2, 3, 4, 5, 6, 7. All right. Okay, so Guardian graphics are from 768 to there, and there are 8 sprites. All right, that's easy enough done. So for our room data, I'm going to have special graphics. I'm also going to have public list byte, and then it's going to be Guardian graphics get set. And then I'm going to make sure I set this up here. So, all right, and just bring this in here. So I want to say that for int I equals 0, I less than 7, I plus plus. Is that right? I think it's right. 0, 1, 2, 3, 4, 5, 6, 7. So there's 8. There are 8. For each sprite. So each of these is 32 because each 32 byte is our 2 by 2 graphic. 8 16 by 16, 16 by 16 pixels, but it's 2 by 2 characters. So we read in byte shape equals importer dot read bytes 32, and then data dot Guardian graphics dot add shape. And then that would be SP as well. And that's it. I think we're done for graphics. The next thing we need to do is we need to actually build the game. So instead of our, so we've read in our graphics now. So instead of that static graphic, I'm now going to get the horizontal Guardian graphic in there inside the room renderer. So instead of that shape there, I'm just going to have it as Guardian Graphics 0. So it's going to pick the first Guardian graphic that it finds for each of the rooms. So we should get that kind of crazy automaton thing in there. Nope. What happened there? Oh. Oh. Guardian graphics. Oh. SP. Oh. Buffoon. Okay. There's our Guardian graphic. I don't know why it does that. I have to figure that one out. I don't know why that does that there. So now we move on to room 1. We should get our penguins. There you go, there's the penguins. And room 2, we should get our little menagerie. Yeah, that is strange. Oh, actually, I think I know why. Whoa, they're not right. They're right. They're supposed to be toilets. I know, it's if you're not used to British humour, no, those are wrong as well. Those are slightly wrong. Yeah, these are wrong as well. So we're missing an offset somewhere because these are getting worse. Well, at least central cavern works. That's good. So there's central cavern. So let's get him moving. So if I move him from, instead of having him as sprite 0, if I make him sprite 1, you'll see what I mean, because he moves, he's still inside his 16 by 16, but he's like that there. So I'm going to get him to move. So that's what I'm going to do in this next bit. So sorry it's taking so long getting this so far, but it's fun. It's coding, you know, it's making a game. All right, so let me just get my bearings here. Okay, so for each horizontal guardian, I want to move him across each tick. Okay, so from the start, so that's going to be, instead of that there, that's going to be g dot start frame. So our start frame for here should be 0, which is right. And then if we go to room 1, I don't know if you noticed, but the penguin was facing, they were both facing that direction there. So now this is right, they're both facing this direction, which is correct because they actually start off inside here and they go that is a bit disturbing there. So I wonder why. Oh, actually, I think I know why. I think I think I know why. I think I'm doing something wrong here when I bring in, not in here, inside the room store. I think I'm doing something wrong inside horizontal guardians. So I'm going to mark this in here to do check this logic because we are getting black areas top left. Okay, so just as a note for later on, and I'm going to fix that later on, but not right now. So my horizontal guardian, I want to have this as like an active guardian, and so what do I want to do? So the start X is there, start Y is there, and then start frame is, how's he got this? 0 to 3 for right facing frames, 4 to 7 for the left facing frames, where sprite 0 to 4 are the leftmost frames, 3 to 7 are the rightmost frames. For smooth horizontal guardians, I suggest having a normative width of 10 pixels, which you shift 2 pixels to the right on each successive frame. Right, that's right. So it goes 2, 4, 6, 8, and then that's you on to the next. Use only sprites 4 to 7 for the horizontal guardian graphics, zooms and vertical guardians. Okay, so for Manic Miner, for their bidirectional graphics. Okay, so rooms that have bidirectional graphics for horizontal guardians. Okay, so I'm going to do this. I want to have, let me look at my horizontal guardian again. Oh, I'm sorry. Okay, so attribute, left, right frame, start frame. Okay, so I want to have let me see, I want to have a horizontal mob. Actually, maybe I just want to have a mob. I just want a mob. C# mob behavior. Okay, that's good enough. And my mob is going to take in public mob, and then I'm going to have that be almost exactly the same as my horizontal guardian. Because this is going to be for each horizontal guardian. So I need to know the attribute, I need to know the start and end, I need to know the start frame, I need to know left and right, and so on. Okay. And I'm going to leave that just as a basic copy just now. Okay, so for each of these, I'm going to tick them separately. Okay, so I'm going to do, what am I going to do? Inside my game screen. Actually, I'm going to do, first of all, I'm going to do public mob horizontal guardian. Actually, it's going to be horizontal guardian G, and it's going to be attribute start x equals g dot start x, start y equals g dot start y, start frame equals g dot start frame, and then left equals g dot left, right equals g dot right. Okay, and then my start frame, I can make that lowercase s, so I can, instead of having that as public int, I can just have it as int, and then I can make that s, and then rename it to that, because I don't need that to be exposed. And then my start x and my start y, that's the same thing as well, so I can rename that, and I can make that private as well, and I can do the same thing for start y. Because again, I don't want these to be exposed, because once they're set, they're set. I do need to have attribute there, and I do need to have left there, leftmost and rightmost, and I also need public int current x get set. Actually, I just have that as x. Public int y equals get set, and then I can do my x equals start x, y equals start y. Okay, so that is my mob, and then I'm going to have an update to that. I also need to have public int frame get set. Okay, and then my frame is going to be start frame. So frame equals start frame. Okay, so start frame is there. Then okay, so then we've got the horizontal movement, which you can sort out in just a sec. Okay. And then I need to know the direction, so I need to have public int frame direction. So I need to know if I'm going that way or that way, if I'm adding or I'm subtracting. That's really just the sign, so it's plus or minus. And I think that's okay. And then inside my controller, so if I go to my game controller, I'm going to have list mob mobs equals new mobs, and then I'm going to go into here, and then when I run this through, I'm going to say this is going to be room data dot horizontal guardians dot for each, and then I'm going to do g mobs dot add g. Oh, it's been new mob g. So this is just shorthand. Rather than using a for each loop, I can just do this in one handy dandy line that says for each guardian in horizontal guardians. What I want you to do is I want you to do this action here. So you see that you can actually take an action, and we'll come back to that in just a sec, because I also want to use actions for drawing things as well, or for updating things. So for each of them, actually maybe I don't need to do that. So for each of the mobs, I want to, so for the room number, 1, 0, 1, 2, 3, 4, 5, 6, 5, 6, 9, and 18. These are bidirectional graphics. Okay, so for bidirectional graphics, I want to say if room ID is greater than or equal to 0, 0, 1, 2, 3, 4, 5, 6, 6, and room ID is less than or equal to 6, or room ID equals 9, or room ID equals 15. And then from here, I want to say start coroutine by directional sprites. Okay, so bidirectional sprites. I'm just going to create a coroutine called bidirectional sprites. It's probably not a good idea, but I just want to get things moving just now. So enumerator bidirectional sprites, So when we draw the screen, what I actually want to do is, instead of passing in the room data, I also want to pass in our mobs as well. So I'm going to create my list of mobs down here, and then inside draw screen, I'm going to accept an iList of mobs because I want to take in these mobile values here. And then instead of drawing the horizontal guardians, I'm going to also take in my iList mobs, and then also need room data as well. Data. And the reason why I need room data is because I need to get the shape. So I'm going to say for each value in mobs, and you can see that I can still use most of these things here, so I can do that, change that to current frame. And then that's going to be the y coordinate, and that's going to be the y coordinate, that's going to be the x coordinate, and that's going to be the x coordinate. Okay, so again, the renderer doesn't know anything, it just updates, it just draws the thing on the screen where it's told. It doesn't make any logic decisions, that's all done inside the controller. And then inside here, I'm going to pass in this data, and then that's going to be mobs. And the controller doesn't know anything about how to render things, it just knows where the data is held. So this is kind of separating the data from the actual values. What time is it anyway? Oy, come on for 2 hours. Sorry about this. Okay, so then we're going to do that there, going to have directional sprites, and then we're going to do for each mob in mobs. And then this is going to be while not game over. And then it's going to yield return new, wait for seconds. I'm going to update this maybe every quarter of a second just now. Just for now, anyway, we'll see how it goes. So this means that all our sprites update every quarter of a second, which is probably too slow, but we'll figure that out. Okay. Now the setup is going to be different for this as well. So I'm going to say for each m in mobs, if m dot frame is greater than, and then what does it say here? Where are they? 0, 1, 2, 3. Less than 4. Then frame direction equals 1. Else, actually, we can just do short circuit this. We can just do frame direction equals frame direction equals m dot frame less than 4. Make that a 1. Make that -1. That's it. So we just want to set this up for the start. Okay, and now we want to tick this. So for each m in mobs, I'm going to wait. Actually, I'm going to wait the first time there. I'm going to put the wait at the start, and I'm going to say m dot frame plus equals m dot frame direction. And so what do we got here? We're moving the frame, so when we get to 4, we want to reset that to the 0th element. Okay, so if m dot frame is if m dot frame is equal to m dot frame is greater than, no, if m dot frame direction equals 1 is greater than 0, and m dot frame is greater than 3, m dot frame equals 0. So we're going to move it back to 0. Okay. So right now we're not moving anything. We're just gonna animate the sprite. So fingers crossed this is gonna work. Okay, well, partial success. Let's bring it back to this guy here. Okay, so he's moving okay. So when he gets to this point here, I want to then say m dot x plus equals m dot frame direction. Then I want to say, so this is if he's heading from left to right. So this is the sprite heading left to right? Have they reached the end? So if m dot x is greater than m dot right, then m dot x equals m dot right, and then we want to say m dot frame direction times -1. We want to point them back in that direction, and then we want to say m dot the current frame equals 7. So they're heading back that direction. And I think that's okay. Otherwise, the sprite is heading right to left. So they're heading right to left. That means we want to do there's nothing else. It's if m dot frame direction is greater than 0, is less than 0, and m dot frame is less than 4, then we want to reset the frame equals 7, m dot x minus plus equals m dot frame direction, because again we're heading that direction. If the current x value is less than m dot left, then we want to say m dot x equals m dot left, so clamp it to the left. M dot frame direction times equals -1, m dot frame equals 0. So now hopefully we should have the sprite bouncing between left and right. Oh, it's exciting. Can't wait to have a guardian in here. And there he goes. Let's see if he stops and turns around. Right, let's see if he hits the other side now. We have a guardian! This is so cool. Alright, so clearly that is too slow. So 1/4 of a second is too slow, so let's make it 1/8 of a second. Yeah, I think that's 1/8 of a second. Let's see how that goes. That looks good. It might be a little bit too slow, but yeah. Okay, so let's see what's wrong with these other ones. Oh, they're okay. So we have 2 now. And so he should hit there and then head back the other way. That's good. Okay. Oh, color clash. Look at that. All right. And then let's just try this one more. So this is a menagerie. There we go. It's quite slow actually. It's kind of jittery. So maybe I do need to make it a little bit more than that. What is 16? This is probably 0.0625. 0.625. 625. Can I get that right? Okay. This is probably too fast. It's not too bad. It's maybe not 16. It's maybe 10 times a second. So 16 is probably too much. So maybe 10 times a second. Yeah, it's a bit too slow. Okay, well, we have guardians though. That's the important thing. And I think that's a good time to stop, rest in our laurels, and we'll pick this up next time. Hi guys, thank you so much for watching. You've no idea. I'm enjoying, as I've said before in previous videos, the Manic Miner videos. They're kind of a labor of love for me. I grew up with this game. It was one of the first games I played on my 48K Spectrum. Not the first game I played on the Spectrum, but it's the first game I played on my 48K Spectrum. And so yeah, I'm really enjoying this, getting this all set up. So we get color clash as well, which is awesome. So if you liked the video, thumbs up. If you didn't like the video, thumbs down. Leave a comment. Subscribe and hit the call button to get timely notifications. And if you like this and you want to pass it on, feel free to use social media and pass out some info, send people to these videos. You don't owe me anything, I know, but if you wouldn't mind, Gavana. Yeah, so until next time, take care, keep coding, and I will catch you in the next video, which may not be a Manic Miner video, but it will be a game dev tutorial of some kind anyway. Alright, so see you later. Bye guys.